Hello and welcome again to another episode of Lost in Science, half an hour on your radio or podcast listening device, where we talk about science. And my name is Stu, and on this week's show, I am going to answer a question that somebody asked me. How much blood can you lose and have it replaced with saline before you stop working, basically?
I hope this person didn't have an urgent need for this question.
No.
It
was a general question, and they were just
Otherwise,
curious.
You should have answered a little bit.
Yeah. I think I sent them to the emergency room before I got the answer out. But no, look, I thought it was an interesting question, and found out some other weird things that they do with blood, including making artificial blood for people in various situations.
They make it artificial blood from blood, do they?
No, they make artificial blood from things that aren't blood.
Oh.
Yeah.
Beetroot, mostly.
It's like corn syrup. Isn't it corn syrup with colouring?
Not fake blood. Oh. This is working artificial blood.
Okay.
Yeah. It's not just the look of it that's important. It's the function that actually makes it work. But anyway, Claire, what have you got for us?
Well, I'm going to be... there's been some exciting research with my favourite moth of all time.
I'd say everyone's favourite moth.
Everyone's favourite moth, the Bogong moth.
The delicious Bogong moth.
The delicious Bogong moth. And if you don't know about the Bogong moth, well, I have a story for you about they travel over 1,000 kilometres to get to the Alpine region. And up until now, no one knows how they navigate from where they hatch to the Alpine region. And it's just been discovered by scientists that they actually navigate via...
Google. No?
Google Maps, yeah.
They all have a little phone and just...
No, they use the magnetic Earth. They use the magnetic field of the Earth.
The magnetic Earth.
The magnetic Earth. Anyway, I'm going to talk all about that and the amazing experiments that these scientists did to prove that.
Do they stick magnets to moths?
Oh, it's even better, Chris. It's even better than that.
Speaking of magnetic, Chris, What have you got for us?
Oh, thanks, Stu. Well, Stu, remember you a couple of weeks ago, you did a story on a famous psychology experiment.
Oh, yes, the marshmallow.
The marshmallows.
Yeah, and didn't, it's like now being re-examined and not quite what it cracked out to be.
I've been telling everyone about that.
Yeah, I thought that was pretty impressive, but I can find a more famous experiment, surely.
That's even wronger?
That's even wronger. So I'm tackling one of the most famous psychology experiments of all time. This is the Stanford Prions Experiment. The one where they stuck students in a fake prison. Some of them were guards, some of them were prisoners, and it really turned badly.
They sat back and with some popcorn and watched what happened.
Yeah, that was the premise of the thing. Anyway, for those who haven't heard of it, I will explain what it's all about. But yeah, some new information has come to light that indicates that it perhaps was not quite what it seemed to be, and maybe some of the big conclusions people have drawn from it are a little bit unwarranted.
And don't we just love debunking things on Lost in Science? Stay tuned for that later in the show. Anyone who's been in an emergency ward or even, watched a medical drama on TV will know that doctors often call for saline.
Stat.
Yeah, and it's always...
CCs. It's always
stat.
CCs.
Yeah, CCs is just cubic centimetres. They could say millilitres, but obviously...
Oh, that's hard. Your tongue trips over that.
Yeah. 50 mils is really hard to say when you're in a hurry. So, they call saline solutions to be administered to patients. So a saline drip is something you commonly see in hospitals, in casualty departments, as well as in post-op wards where patients recovering from surgery are resting. So what is the saline for? Well, basically, saline is just salty water. It's a solution of about 0.9% sodium chloride by weight per volume of water. And it's an intravenous solution. So they do use it for other things, like people wash their contact lenses and stuff with saline as well. But this is
boil your pasta in it?
You probably could, yeah. It would be very salty though.
You're supposed to boil your pasta in salted water, aren't you?
Yeah, only for flavour though. Yeah, there was an old thing about, it makes the water boil quicker, but the difference is negligible. So the reason that they use this concentration of 0.9% is that it approximates the osmolality of blood, which is basically to do with how water moves in and out of cells.
Osmosis.
It's
osmolality.
Osmolality, not osmolarity, which is a different measure of something. But basically, if the blood was too salty, it would suck water out of cells. And if it wasn't salty enough, it would get sucked into cells. So it would, your blood would dry out, basically. So they've got to have it at this particular concentration so that it works kind of like blood serum, which is the liquid part of the blood. So sometimes they also use a low sodium version. So if people are massively dehydrated or they have to be on a drip for a really long time, they drop the amount of sodium in it and boost it up to keep the osmolality the same with dextrose, which is a sugar. So basically you're getting fed out of the drip as well. So the reason I investigated this is because someone asked me the other day, how much of someone's blood can be replaced by this saline solution? And I had no idea. So I went and found out. And it seems that in humans, up to about half of our blood can be replaced by saline solution and you can survive. But obviously, it's not replacing all of the functions of blood. One of the most important ones that blood does, one of the most important functions it has, is delivering oxygen. So salty water is not very good at delivering oxygen. It's just good at basically keeping your veins open. So also blood carries nutrients and hormones and oxygen to tissues around the body and also removes waste products from the cells. So saline is just not really cut out to do some of that, or to do most of it, basically. So in some emergency applications, for example, in the military, they use artificial blood. If someone loses too much blood, they actually have artificial blood, which has many of the properties of real blood.
Wow.
And can carry oxygen and, does all of the other functions that blood does. It's really expensive, though.
Okay.
So it's not commonly used, especially when you've got access to whole blood, which hospitals usually do because they just keep it in the fridge. But if you're out, on maneuvers in the military, then you can't refrigerate the blood. So they have this artificial blood that they can take with them.
So the artificial blood doesn't need to be refrigerated?
No, which is, it's one of the reasons.
It just comes in a Tetra Pak.
Yeah, like just a Prima thing, and they just poke the straw in there. And no, I'm sure it's got, pretty secure packaging because you wouldn't want it to leak out everywhere. It is apparently very expensive. And most hospitals, they just use whole blood because they have fridges full of it. Well, they should have fridges full of it, and if people want to go and donate, they should do that because that's a very useful thing to do with your blood if you have some to spare. And
according to you can spare about half of it. So,
well, I'd say they usually take not very much when you go and donate. It's only sort of half a litre at a time, I think. So recent research into severe blood loss has shown that having a solution that has a higher osmolality than blood is actually sometimes a better option than using this 0.9% saline solution. So they actually found that...
so that's a high concentration.
A higher concentration of
salt.
salt.
A salty concentration.
Yeah, and even saltier. And what they've found is that actually draws liquid towards where that solution is. So it actually, if someone's lost a lot of blood, there's sort of lost the connection with their extremities of their limbs and stuff. So this higher osmolality saline actually draws fluid towards it. So it actually gets the blood flowing again, which avoids, problems with gangrene and lack of oxygen and things like that.
So is that something that they might do initially, like use a higher osmolality initially and then lower the osmolality?
Yeah, it's kind of an emergency treatment to sort of get the blood flow happening again, and then they'll probably wean them off it once there's sufficient liquid in the body. So one of the other things in biology, one of the most important factors is temperature, and most cell function is highly temperature dependent, which is why we have a stable, constant temperature of 37 degrees or thereabouts, plus or minus a little bit, but it can't go up and down too much. If it gets too hot, proteins and enzymes get denatured, and if it gets too cold, they stop working altogether. And blood is a way of helping to regulate that temperature by removing or restoring heat to hot or cold parts of the body. Now, in the US military, a medical team have proposed that using a massive temperature drop to save patients who might not be able to survive surgery. So they're talking about people with major, wartime kind of injuries. And what they're suggesting is that they can replace all of a patient's blood with a supercooled saline solution, which allows doctors several extra hours to operate on severe injuries. And then they pump all their blood back in and resuscitate them, and they come back to life. Now, it sounds pretty, science fiction-y. It's like suspended animation kind of procedure. And this is a proposal, and they've actually only been able to do it with pigs. So they've actually done this with live pigs and super cooled them and operated on them and then brought them back to life again. They haven't actually managed to do it with human subjects yet. And there's a bit of an issue with consent, because a lot of the patients that they're trying to treat are unconscious on arrival, so they can't actually consent to an experimental procedure. So they've got a bit of a problem with that. But they're saying that they might be able to complete human trials in the next couple of years, and then they'll be able to publish results. But it's, they've been talking about it since 2012, and they've got these animal models where they've done it, but they can't actually step it up to humans because of ethics approval is the main thing. They can't actually get it. But it's an interesting concept. If you could actually replace the blood and keep the body intact, how long can you sort of stretch it out without having any blood? Because you're not actually, you're sort of putting a refrigerant in the bloodstream instead of the blood. So it's an interesting idea. But so if these guys do manage to succeed in their experiments, they will be able to literally replace all of your blood with saline solution, and you will still survive, which is kind of amazing.
Super cool.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
So some new research has come out recently concerning my favourite Lepidoptera of all time. That is from the family of moths and butterflies.
So you prefer it to like the monarch butterfly and those kind of things?
Yeah.
Monarch butterfly is not even an Australian butterfly.
Yeah. Well, okay, so what I'm talking about...
It's an invasive species, though.
Can you guess what I'm talking about?
Bogong moth.
The Bogong moth, that's
Yeah.
right. Right, not the Bogan moth.
No, as some might call it.
As some might call it. That is something different. Bogong moth. They are incredible insects. Possibly some of the most incredible insects. Not necessarily to look at. In fact, they're pretty plain looking. Very unassuming, small, brown.
Well, they're not that small.
A little bit like me.
There's some pretty big ones.
Bogong moths?
Yeah, they get quite large.
They do get large?
Yeah.
All right. Unassuming, large, brown. But these little moths make big journeys every year. Each spring, billions, not millions, billions of Bogong moths hatch in southeastern Australia and also in Queensland before flying 1,000 kilometres through the dark night to finally arrive at Australia's Alps, the Australian Alps, and more specifically to a certain alpine cave. So they
Just the one cave. There are billions of them go to one cave.
Oh, no, like caves, but there's like, Yeah, there's a couple of caves, but there's not that many caves. I mean, but there's got to be more than one cave. You've got 1 billion moths you're talking about.
The moth cave.
It's the moth cave. And why do they go? To breed,
Question.
to feed, to get away from Queenslanders? Sorry, Chris. No. They come to the Alpine, they head to the Alpine to have a holiday, to cool off and hibernate over the summer.
Oh, so they don't do those other things.
No, they don't do those other things. It's just to hibernate and to hang out in the nice, cool caves of the Alpine Australia. What in the off season for skiing, so they don't have to put up with all the yuppies on the slopes. Anyway, after a few months of summer dormancy in the cool mountain caves, the moths fly right back to the breeding grounds where they were born. Now, up until now, it's only been guesswork as to exactly how these moths make their way from Queensland, Victoria to the Australian Alps. As they're nocturnal, there have been some suggestion they could be navigating by the stars or via environmental landmarks like mountains. But one thing that scientists weren't totally sold on was that these little moths were navigating via the Earth's magnetic field. In fact, they were sort of like, invertebrates, magnetic field. I don't think so. They really didn't even think that was going to be the case.
I see. I'm always surprised when people claim like vertebrates, like complicated animals are doing it. Complicated animals. Like there was a story did a report on a while back of like cows being magnetic, and that's just kind of go, nah, that sounds unlikely. I'd accept a moth being magnetic more than I would a cow.
Really?
Yeah.
Well, I mean, when you think of animals who migrate via the Earth's magnetic field, you think of birds and you think of turtles, and even some fish have been known to navigate via the Earth's magnetic field. All vertebrates, cows, also vertebrates. Did you say cows actually migrate? No.
No, they don't migrate, but
No.
they seem to
Totally orient themselves.
orient themselves with the magnetic field.
Right, okay. So, anyway, they found that moths actually can migrate via the Earth's magnetic field. And in a paper published in Current Biology, the researchers tested how the moths react to moving visual cues and also to magnetic fields. Now, to do this, they created what can only be described as a tiny little moth flight simulator. So imagine a cylinder with a pole in the middle, like a round room on a platform. Anyway, around the edges of the cylinder, you have these pretend visual landmarks. So things, like felt stuck to the walls that might look like a mountain or something like that.
They made them a little fuzzy felt mountain.
Yeah.
Diorama.
Yeah.
Basically.
Yeah, they made a tiny little moth diorama. And then they hung out in Narrabri in New South Wales, as you do, and caught them on their way down to the Alps. And then they also did it again when they were heading back to Queensland, caught them again, to test what would happen when they put them in this tiny little moth diorama. Anyway, obviously you can't just let a moth go in this diorama. You need to tether it somehow.
Why? How big is this diorama?
Well, it's pretty small. It's like, I don't know, a bit over 30 centimetres, a little bit more.
So why couldn't you just let the moth go? It's not like it's going anywhere.
No, but you want to measure like how it actually orientates itself.
Oh, okay.
Because you've got these visual cues around the sides of the cylinder, and then you're also applying this magnetic force.
Okay.
So you've got this magnetic force and the visual cues, and you got these tethered moths, and so they started. So the moth's in the middle, and the researchers then started to move the cylinder and the magnetic field at the same time and see what the moth would do. And when this happened, the moth's flight direction and their head, they orientate themselves in a different way, as predicted you would if you were noticing, using a compass, and then the compass said one thing, and the landscape said one thing. Then you're like, oh, this is the way I'm going. This is the direction that I'm headed in as a moth in a tiny little moth diorama.
But what was the landscape? I mean, did they do an accurate landscape that the moths would encounter? Like, did they do like the Narrabri countryside, which I think is fairly flat generally, or did they like just random mountains and things? And
I think they were like random mountains, but just things that were like visually different.
Right.
Yeah. So it was like the difference between.
But the moths go around, I don't know where I am amongst all these felt mountains.
The moths have no idea where they are.
Get the compass out.
Just turning. But if they moved just the visual landmarks, like just the mountains, but kept the magnetic field in the same place, then the moths became totally disoriented and got all muddled up and started moving everywhere. So move the visual landmarks and the magnetic field in the same way, and moths are heading in the same direction.
They got a sensation that I'm moving, I know what I'm doing.
Oh, I know where I'm going, I'm heading in this direction. They all moved in the same way. But if you move them at odds with one another, they're all like, what? What's going on? In moth language. Anyway, so this suggests that for the researchers, that the moths need both the visual landmarks as well as the magnetic cues. And the moths check in on both pieces of environmental information on an ongoing basis. So, I mean, just like us, when we would be, when we're out in the wilderness with a map, a compass, and, just our senses, then we're also, checking to orientate ourselves with the compass. We're looking at the mountains, we're looking at trees and rocks, and, updating our position in the world based on that. And that's apparently what the Bogong Moths do as well. So there we have it, the first reliable evidence that insects are much cleverer than us in some ways.
Okay, yes, you are listening to Lost in Science. My name is Chris, and I'm talking about the Stanford Prison Experiment. Do you guys know what the Stanford Prison Experiment was?
Yeah.
Yeah, I know it went horribly wrong.
Well, yeah, supposedly. That's the way the story goes.
Or did it go horribly right? I mean, what were they trying to test anyway?
Well, it kind of did what they were meant to do. So the story was basically that...
it ended in torture, didn't it? Sorry, go on.
Okay, the story, it took place in 1971, so back before ethics. It involved, it was set up by psychologist Philip Zimbardo, and he assigned college students as participants to either be guards or prisoners. And the result of the experiment supposedly was that the guards just turned really cruel to the prisoners who were in their charge. The experiment had to be stopped early due to the effect it was having on the prisoners. Apparently, his girlfriend came back from a trip and saw what was going on and said, "You've got to stop this, Phil." So that's the official story.
So the guy who set it up didn't think that there was anything wrong with what he was doing, presumably.
Well, again, that's the story. But recently there has been some more information coming out. There was an expose published on the website Medium by the journalist Ben Bloom, and there was a book published by a French academic Thibault Le Texier that went back and examined some of the original documents from the experiment and some audio tapes of what was going on. And together these two bits of journalism, they've showed that the experiment wasn't quite what it seemed. And, people like to draw conclusions from this experiment, so what it means for human nature, and that maybe some of those conclusions aren't quite valid. People have been jumping to conclusions. Because it says a lot to us, I think a lot of us, we think about, this is, how people will turn cruel if they put in a position of authority. So it basically says things about, we all have an innate capacity for doing bad things, but also it's kind of been a way to excuse bad behaviour in the basis of, I'm in the system that encourages bad things to happen, so it's not my fault if I do something wrong because everyone does it. and that was actually used as a defense with the Abu Ghraib thing in Iraq. That they basically went, oh, look, this is how guards in prisons behave. That's what the psychology experiment said. That's life. So,
Yeah, and there's no responsibility.
yeah.
Yeah.
So it's a very significant experiment from that point of view. So anyway, so most tellings of the story, the most dramatic event, and this was also featured in the 2015 movie, The Stanford Prison Experiment.
It was a movie?
There was a movie. I think it starred Billy Crudup and Ezra Miller. Ezra Miller played this prisoner, Douglas Corpy, who had an emotional breakdown. He has this big, very intense breakdown where he's going, oh, I can't take it anymore. Anyway, but he has since said that he actually faked the breakdown because he was just a bit fed up. He thought he was going to go on this thing as a nice kind of break. He could study for grad school. They wouldn't give him his books, so he put on an act to try and.
So he faked it. He did like what they do in the soccer when they get a little tiny injury and they roll around on the ground as if they've been mortally wounded.
But as long as he got a penalty after it, then that's okay.
Well, see, thing is though, as much as he said he was faking it, one of the other things he did say was that they had told him also that he wasn't allowed to leave because he would thought, I'll just go out and study. They told him he wasn't allowed to leave. And the records and one of the statements from another participant backed that up. So instead of this being an experiment with people with fake prisoners, they were actually real prisoners in the sense that they were told they couldn't leave. And that's kind of illegal as well.
Yeah.
And furthermore, the guards actually didn't spontaneously decide to be cruel. So the techniques that they used to torment the prisoners, they were suggested by a former prisoner who was hired as a consultant. And there was a student who was in the role of the warden, had actually tried an earlier version of this experiment, and he had come up with a few of these ideas. And in their induction, the guards, Zimbardo actually encouraged them to use their power to create, as I said, boredom and frustration and fear in the prisoners. So some of the guards have said that they performed a role. They thought that was what Zimbardo wanted to see. They wanted to see them acting up and being cruel. So that's the role that they played. So now I guess some psychologists are saying that the Stanford experiment wasn't so much a display of everyone's kind of innate cruelty as about leadership. As in, if someone tells you to do bad things, you will do bad things, essentially, because that's what Zimbardo did, effectively, according to the records that have come to light. So there was an attempted replication of the experiment done in the year 2002. Psychologists Alex Haslam and Steve Riker, they worked with the BBC on this. So it was done in the age of ethics. And so the things were a little bit different. The prisoners in this case were told that they could leave. The guards weren't given instructions to be cruel. In fact, they weren't given much instructions at all. And the results were extremely different. Like the guards had
I think I've heard of this one. Is it called Big Brother?
It was televised. It was just a BBC prison experiment. There's a TV show called The Experiment. So the guards, they felt uncomfortable in their position of power. They were kind of very unsure of themselves and divided about what to do. Whereas the prisoners essentially didn't like the way they were treated, and they rebelled against the guards. It went through a brief period of democracy until some prisoners decided that they wanted to take over, and they stopped the experiment at that point when people were they reached an impasse that could not be solved without resorting to violence, which of course they didn't want to have happen. So, but the thing is, it was very different. It was very different to the Stanford experiment, where supposedly the guards straight away turned cruel on the prisoners. This is kind of the opposite. The guards were at the mercy of the prisoners because the prisoners identified with their group of being prisoners, and the guards were like, oh, we don't want to torture these guys. But one of the things that they claimed this experiment showed was, again, when leaders emerged in the group, and they were able to direct people and say we want an authoritarian regime, that was similar to what Zimbardo was doing in his original experiment, where he was basically the authoritarian leader and telling them, this is what you need to do. So the experiment has been increasingly discredited in the psychology community. It's being removed from textbooks gradually, but it's kind of got a huge effect on popular culture, and it's going to be a long time till it is removed, I think. People say a lot of bad things about psychology. There's this whole thing they talk about, the replication crisis, where there's a lot of trouble replicating famous psychology experiments. They don't work out the same when you try and do them again. So people say, this is means a fundamental problem with psychology. I think there's some things that suggest that maybe psychology is not uniquely bad compared to other sciences, but I think one of the things about psychology is that we draw such big conclusions of it. We look at its impact on society, and we jump to conclusions based on single studies like this one, sensational studies. And perhaps we should be a bit more cautious because it is science, and you have to wait till things are replicated and are actually real before you, I don't know, assume that this is the way that society is and the way that human nature is.
That's all we've got time for on this episode of Lost in Science. Thanks for tuning in and joining us. Lost in Science is recorded at the studios of 3CR in Melbourne and broadcast across Australia on the Community Radio Network with the financial assistance of the Community Broadcasting Foundation. If you want to talk to us, talk back to us, you can get in touch. We have a Gmail account, lostinsci@gmail. You can also find us on Twitter and on the Facebook. And if that's not enough Lost in Science for you, you can always tune in again next week, where the team will once again get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.